Okay, all right. So now we go to the Adder-Subtractor circuit. Okay, so Adder-Subtractor circuit is not a new circuit, okay, but it's a combination of the Adder circuit and also the subtractor circuit. So we are all because the Adder circuit and subtractor circuit is almost identical because they use the same full adder. So therefore, we can combine the adder and subtractor circuit into another circuit we call as an adder subtraction circuit, because since they are almost the same, okay, using a full adder but different gates, okay, therefore we can combine, okay, these two circuits to become as one circuit as an adder subtractor circuit. But in this circuit, we have to put some additional input we call a control input. Okay, so this control input, okay, will be controlled either to do the operation of the additions or subtraction. If you want to do the additions, okay, so your control input is become 0. So then the circuit will perform the additions. And where your Cin wire as the first bit will become 0. Okay, if you want to do the subtractions, so your control inputs will become automatically become 1, always 1, and the circuit will perform the subtraction circuit because we have A plus B plus 1. Okay, so therefore the first bit of the full adder for the adder subtractor is become 1. So how does the circuits look like? Okay, because these circuits need to have a controller. So this controller, so what kind of gate that should be suitable in order to control, okay, your bits to do the either to do the additions or subtraction. So now we can construct the truth table, okay, based on the operations given. Okay, for the controller. Okay, yang pada soalan tadi tu adalah controller. Okay, so if you add, controller becomes 0 and then your perform is B. And then if you subtract, okay, the controller become 1 and this will become a B bar. Okay, so become B. So we focus, we put the controller at the B as the input B, not A. Okay, so therefore that's why you have the B and B bar. Okay, therefore what we can do is we can write the expression as y equals to, okay, B, alright, dot control, bar control plus B bar dot control is actually is a B circle plus control. Okay, right. So therefore we can conclude that, okay, we will use a exclusive OR gate in order to perform as a controller when they have operations of additions and subtraction in the adder subtractor. So therefore, when the control input is 1, the input Cin1, okay, and the exclusive OR gate will act as inverter to perform the subtraction. So therefore, your exclusive OR will be used as an inverter when they perform a subtraction operation. If you do some addition operations, so your exclusive OR will become no effects. Okay, so your Cin is 0, then the exclusive OR gate will become 0, and then when they have exclusive OR, then it doesn't change. Okay, it doesn't affect, okay, at all. Alright. So that is how the adder and subtractor. So adder subtractor ni dia tak adalah benda yang berbeza, cuma kat sini kita ada satu controller saja. Okay, dia boleh buat dua-dua, tapi sama ada dia boleh buat addition atau subtraction. So we can use the controller. So kita kena ada satu controller kat sini in order to control sama ada kita nak buat operation tambah ataupun tolak. So that's why ada sedikit berbeza antara adder subtractor dengan subtractor. Kalau subtractor tadi kita pakai NOT gate, okay, tetapi untuk adder subtractor we will use a exclusive OR, okay, as a gate. Okay, alright. So therefore, okay, we move to, so now we move to the Okay, examples. Okay, this is example of the 4-bit adder-subtractor circuits. Okay, in order to perform 7 minus 6 operation. Okay, so as you know, okay, we can convert this 7 minus 6 into the binary. Okay, of course you have to convert into the binary. So 7, okay, you convert into a binary as a 0, 1, 1, 1. Alright, and the 6 actually is 0, 1, 1, 0. 6 you convert into a binary is 1. Okay, and then don't forget, since okay they are using subtractions, okay, you have to understand that your control input, okay, will become 1. Okay, and your Cin is become 1. Okay, so therefore this one you have to add 1. So this is your Cin. Okay, and don't forget your 6 need to be bar. You don't have to bar because we will use the exclusive OR as a inverter. Okay, so ni lain sikit. Okay, berbeza sedikit dengan you punya uh, subtractor circuit tadi ya. Okay, so now we go into your circuits. Okay, so in the exam, if they ask you to draw, okay, so draw the full adder-subtractor circuits. So you have to draw, depending on the number of bits. Okay, so you have a 4 bits, they have a 4 bits of full adder that we use. Okay, and you have a Cin. Okay, so since you are using to perform a subtraction circuit, so your Cin become 1. So it's color. Okay, Cin you become 1. Okay, and your controller is become 1, always 1. Okay, so you put all the gates, okay, it's become 1. Okay, all right, now we go to the set. This is the A1 B1, A2 B2, okay, A3 B3 set lah, set B, set of the bits okay. All right, so the B1 B2 B1 B2 B0 B1 B1 B2 B3 B4, sorry, and then this is your Cin. Okay, all right, so as we do a perform operation, so this one, okay, kita put into the binary, so 7. Okay, so the rightmost bit must be at the top. Okay, so A1 it become 1. How about the 0? How the B1 is 0? But this 1 0, okay, we need to use exclusive OR. So exclusive 1 0 is 1. Okay, so we have these 3. Okay, so 1 plus 1 plus 1 is 1. Okay, your sum is 1. Your carry out also become 1. So, nampak tak? Dekat sini, your punya B1 ni tadi sepatutnya kita bar kan? Tapi, kita tak payah barkan dia kerana dalam gate nanti kita akan tengok ni dua ni dia akan jadi bertindak sebagai inverter. Okay, so 1. So, this one, the carry out of set of B1, okay, the set of 1. Dan the carry out 1 ni akan pergi jadi the next carry in. There's a carry in for the next bit. Okay, so now we go to the set 2. So the set 2 is 1. Right? So how about the B2? So B2 also become 1. Alright? Sorry, 1. Okay, so 1 1 is become 0 for exclusive OR. Remember? Okay, kalau bit yang sama ataupun bit yang sama, dia akan become 0. Okay, so 1 1 0. So 1 1 0 is 2 1 0. So sum 0, 1 of carry out. So the carry out will become a carry in to the next bit. Okay, alright. So we have the third bit. So the third bit is also 1. A3 is 1. So B3 also, okay, B3 also a 1. Okay, so 1 plus 1 exclusive or 1 is 0. Okay, so 1 1, okay, will be your 0. Your carry out will become 1, and it become a carry in for the next, for the fourth bit. So for the A4 is 0. So B4 is 0. So 0 exclusive or with 1 is 1. So therefore your sum is 0 and your carry out Okay, it become 1. So this one is to be discarded lah. So your answer should be 0. So your answer should be 1. Okay, 1, 0, 0, 0, and this 1 will be discarded. Okay, because it's only 4 bits. Okay, alright. So then this is how you draw your 4-bit subtractor by showing the bits. Okay, how the bits are going into the wires for each input and also the output. Okay, so remember for adder-subtractor we must use exclusive OR gate. Okay, kalau subtractor kita kena pakai NOT gate. So kalau adder macam biasalah. Okay, you tambah macam biasa. Okay, tak ada masalah. Kalau you tambah pun, kalau ada negative number, so you boleh pakai sama ada subtractor ataupun adder-subtractor. So based on the questions. Okay, so if they ask you whether using a adder-subtractor or subtractor, so you have to they ask you to draw the 4 bits adder-subtractor. This is the answer. If you're using a subtractor, then you have to use it again. Okay, alright. So I think that's all for the adder-subtractor circuit.